Hello! Yeah! And welcome to our Objective 10 notes. Now, Objective 10 says I can evaluate functions and apply it in context. This is one of the most important skills we're going to get Algebra 1. It's the ability to use function notation, understand what it's saying. I'm excited to dive into it today. So let's start by defining what function notation is. So this is what function notation looks like, where it's just f of x. And that's how we say this. We say f of x. Alright. Now, in equations, f of x serves the same purpose as y. So x is still the input, and now f of x is what we recognize as the output. So whatever is in the parentheses is our input. And then this f is a label. Really, you could even go so far as to call it a name. So for function f, we're putting x into the equation. That's designating our input. What that allows us to do is look at specific inputs, right? Because we can change x. We can make this a number, and then that would be the number we put into our equation as the input. Let me show you what we're talking about. So looking at letter A here, it tells us to evaluate the following functions for the specified input. Write your answer using function notation. So we're going to do that, and then we'll also write it as a coordinate pair. So looking at letter A, we have f of n equals 3n plus 1. Find f of 4. So what that means is 4 is going to be our input into this function f. Now it tells us f of n is 3n plus 1, so that means that f of 4 is 3 times 4 plus 1. Does that make sense? I'm changing my input from n to 4. Well, 3 times 4 is 12. 12 plus 1 is 13. So that tells me that f of 4 equals 13. And that's it. Now, that's it in function notation. As a coordinate pair, what would I write this? Remember, it's input comma output. So my input was 4. My output was 13. My output was 13. So there it is in function notation, and here it is as a coordinate pair. All right, let's try a couple others. So looking at letter B, f of x equals x squared plus 3x minus 2. Find f of 2. So it's telling me to input 2 anywhere there is an x. So I'll say f of 2 equals 2 squared plus 3 times 2 minus 2. Once I've done that, all I need to do is simplify. So I'd say 2 squared, 2 times 2 is 4, 3 times 2 is 6, and then minus 2. 4 plus 6 is 10, 10 minus 2 is 8. So we find that f of 2 equals 8. What that says is for function f, if you put in 2, you get out 8. All right. Now, as a coordinate pair, that would be the point 2, comma 8. There we go. Let's try another. G of x equals x minus 3. Find g of negative 2. Well, so this would be g of negative 2, which means anywhere there's an x, I'm putting negative 2. Negative 2 minus 3 is negative 5. So g of negative 2 equals negative 5. Excellent. As a coordinate pair, that'd be the point negative 2, comma negative 5. My input is negative 2. My output is negative 5. All right. Let's try a few more together, and I'll let you do some on your own here. Let's try letter D. G of n equals negative n squared plus 3n plus 2. All right, so this one, we're going to have to be sure to follow our order of operations. So we're inputting 5. So it'll be negative 5 squared plus 3 times 5 plus 2. So when I'm simplifying this, I know to do my exponent first. So I would have negative 5 times 5 is 25. 3 times 5 is 15, and then plus 2. So negative 25 plus 15, that would be negative 10 plus 2. Negative 10 plus 2 is negative 8. So I'd find that g of 5 equals negative 8. There it is in function notation. And in coordinate pair, input is 5, output negative 8. There we go. There it is as a coordinate pair. Looking at letter E here, the square root of k plus 21. minus 3, find h of 4. All right, so instead of h of k, we'd say h of 4, and anywhere there was a k, we would now put 4. So we'd say 4 plus 21, then minus 3. 4 plus 21 is 25. So the square root of 25 minus 3, the square root of 25 is 5. And 5 minus 3 is 2. So we'd have h of 4 equals 2. As a coordinate pair, my input was 4, my output was 2. There we go. All right, one more together. K of t equals negative 2t squared minus 5. Find k of 3. So k of 3 equals negative 2 times 3 squared minus 5. So order of operations, got to do my exponent first. So I'll have negative 2. 3 times 3 is 9 minus 5. Negative 2 times 9 is negative 18. Negative 18 minus 5. And negative 18 minus 5 is negative 23. So we find that k of 3 equals negative 23. And as a coordinate pair, that would be the point 3, comma, negative 23. 3 was my input, right? 3 was the input. Negative 23 was the output. There we go. All right, what I would like you to do is I'd like you to try some on your own. So why don't you go ahead and try G, H, and J. Let's try this row of problems here. Go ahead and try G, H, and J on your own. Pause the video, give it a shot, and then we will check it together. All right, let's go ahead and see how we did here. So looking at letter G, f of t equals the square root of 6 minus t, all minus 2. And I want to find f of negative 3. So I would say f of negative 3 equals the square root of 6 minus negative 3 minus 2. Now if I'm subtracting a negative, I'm really adding, right? So the 6 minus negative 3 would become 6 plus 3, which is in fact 9. And what's the square root of 9? 3. 3 minus 2 is 1. So f of negative 3 equals 1, which is to tell me that my input is negative 3 and my output is 1. Fantastic. All right. Looking at letter H, g of a equals 5 minus 2a, find g of 10. So I would say g of 10, so 10 is my input. Anywhere there's a variable, I'm going to put 10. So multiplication first, 2 times 10 is 20. 5 minus 20 is negative 15. So that tells me that g of 10 equals negative 15. And as a coordinate pair, I'd write that as 10, comma, negative 15. Input, comma, output. Very nice. All right. Hopefully we're doing good. Let's check out letter H. H of x equals negative 3x squared plus 4x. Find h of negative 2. So h of negative 2 will equal negative 3 times negative 2 squared plus 4 times negative 2. All right. Order of operations is going to be tricky here. Let's start with this exponent, negative 2 squared. So negative 2 times negative 2 is just positive 4, right? Negative times a negative gives me a positive. And then I need to do this multiplication. Negative 3 times 4 is negative 12. 4 times negative 2 is negative 8. Negative 12 minus 8 would give me negative 20. So h of negative 2 equals negative 20. There it is in function notation. And now as a coordinate pair, negative 2, comma, negative 20. All right. Let me know how we did. Raise your hand if we have any questions. Otherwise, let's try this last row here. So why don't you go ahead and try K, L, and M on your own. Pause the video. Let me know how we do with K, L, and M, and then we can check our work together, all right? All right, let's see how we did here. Looking at letter K, h of x equals 2x squared minus x plus 3. Find h of 2. Okay, so h of 2 then would equal 2 times 2 squared minus 2 plus 3. So I've got to do my exponent first. 2 squared is 4, so this will become 2 times 4. I'm going to go ahead and do negative 2 plus 3 as well. Negative 2 plus 3 is just 1. 2 times 4 is 8. So I'm left with 8 plus 1, which tells me that h of 2 equals 9. So there it is as a in function notation. As a coordinate pair, I would have the pair 2, comma, 9. All right, input, comma, output. Let's look at letter L. B of x equals x squared plus 2x minus 8. Find b of negative 4. So I would say b of negative 4 equals negative 4 squared plus 2 times negative 4 minus 8. Well, gotta do my exponent first. So negative 4 times negative 4 would be positive 16. Multiply 2 times negative 4 would give me negative 8. And then I'm going to have minus 8. Well, 16 minus 8 is 8. 8 minus 8 is what I'm left with. So 8 minus 8 is just 0. So that tells me that b of negative 4 equals 0. There it is in function notation. And as a coordinate pair, my input was negative 4. My output was 0. Negative 4 comma 0. Very nice. All right, last one. F of x equals 2x times the quantity x minus 3. Find f of 1. So that means I'm going to plug in 1 for x. So I'll have 2 times 1 times 1 minus 3. So let's simplify these parentheses first. So 2 times 1, 1 minus 3 is just negative 2. 2 times 1 is 2. 2 times negative 2 is negative 4. So f of 1 equals negative 4, which is my solution in function notation. As a coordinate pair, my input was 1, my output was negative 4. All right. Let me know if you have any questions over any of these. Looking at function notation, this was a lot of good work we just put in. Nice work. So this was looking at function equations. Now what we're going to do is we're going to evaluate functions from graphs and from tables. So what I would like you to notice here is the similarities here. So they're telling us, this is our title of this graph, f of x. So they're telling us everything in this table is related to the function f of x. We have our inputs here, we have our outputs here. Now to do this, all we need to do is the same idea that we did above. We're going to find where our input is and see what output it produces. Now up above, we had to solve for that output. In this case, we're going to be able to just read it from a table. So looking at letter A here, f of 0. Okay, so 0, remember, is my input. So I'm going to find where 0 is listed under inputs right here. What output is related to it? 7. So that tells me that f of 0 equals 7. And that's all we're doing. All right, f of negative 3. My input is negative 3, so my output is 1. Now looking at f of 5. My input is 5, my output is 17. F of 1. My input is 1, my output is 11. All right, does that make sense? Let's try another. Let's try letter B here, g of x. So remember, whatever is inside the parentheses, that's the input. So my input is negative 3, which means that my output is 9. My input is negative 4, which means my output is 16. When my input is 0, my output is 0. And when my input is negative 2, my output is 4. Very nice. All right. Why don't you go ahead and try letter C on your own. Pause the video, fill in the blanks here, and then we'll check that together. All right, let's see how we did. H of x here, when my input is 4, my output is 2. When my input is 64, my output is 30. When my input is 8, my output is 4. When my input is 32, my output is 25. Fantastic. All right. Let me know if you have any questions about using a table. Let's move on to looking at graphs. So this is the same idea. All right. So my input, remember, represents the x value. All right, my input. So what they're asking for here is what y value does the point that has this x value have? All right, so looking at b of negative 2, I see it right here. b of negative 2, what y value is that out? What output does it have? 0. All right, looking at b of negative 3, that's this point right here, what output does it have? Well, it's at 1. That's the y value, right? B of 5 right here. Let's see. It also has a y value of 1. Remember, that's okay. They just can't have the same x value producing multiple outputs. B of 2. So when x is 2, what is y equal to? Y is equal to negative 5. And B of 1. When x is 1, what is y equal to? 4. All right. And that's all it is reading a graph. That was B of x. Let's try letter E here, C of x. So C of 4. I want to find when x is 4, what is y? Well, that would be negative 5. What about C of 0 here? When x is 0, what is y? Well, that looks to be 3. C of 8. When x is 8, y is, that looks like negative 3. C of 2. Alright, when x is 2, y, I'd call that negative 1. C of negative 2. When x is negative 2, y is, let's see, what would that be? 7? There we go. Alright, and that's all it is. We're just finding, when given this x value, what output or y value is produced. So with that being said, why don't you try letter F on your own? Go ahead and pause the video, try letter F, see how we do. Alright, let's check how we did here for letter F. So D of negative 4. So when x is negative 4, and I realize this is hard to read, looks like right here, it looks like y is 0. D of negative 1, which would be right there, so that looks to be 2. D of 2, when I go down here, that'd be negative 2. D of 5 also looks to be negative 2, and D of 4 looks to be 0. Alright, raise your hand if you have any questions about reading a table for input output, reading a graph, any questions about anything we've done so far. Please raise your hand, happy to help. Last thing we're going to do is an application here. Alright, we're going to do a few of these. So the table below represents the number of students enrolled in Algebra 1 the first 5 years that Olathe Northwest was open. Cool. Here's the table. So ETS is our year open. That's our input. And F of ETS, the number of students in Algebra 1, that would be our output. Find F of 3. Alright, well, when our input is 3, my output is 127. Explain what F of 3 means in the context of the problem. So what we mean by that is explain what these numbers, as a coordinate point to be 3, 127, what does that mean? So use the context here. So after being open, three years, the number of students in Algebra 1 was 127. And that's all we need for this explanation. One sentence just explaining f of 3 equals 127, or 3, 127. Number of years, number of students. After being open 3 years, the number of students in Algebra 1 was 127. All right. Why don't you try number 2 on your own here? All right, go ahead and try number 2. Find f of 2, find f of 3, find f of 4, and then explain what f of 5 represents in the context of this problem. All right, let's see how we did here. So find f of 2. Well, when my x value is 2, and that's time in days, it looks like my y value is 8. Now this is in thousands. So if you wrote 8 or 8,000, that is totally fine. No issue there. But so looking at f of 3, when 3 days have passed, how many bacteria do we have? It looks like 9. And again, you could write 9,000, that's fine. f of 4, we're going back down now, so we're back down to 8. And it says, explain what f of 5 represents in the context of this problem. So f of 5, so 5 days. It looks like that coordinate point there would be the point 5, comma 5, it looks like. So that tells me, in the context of this problem, after 5 days, there were, plural, there were 5,000 bacteria. And if you didn't write exactly that, that's okay, as long as this is the same idea. Feel free to raise your hand, and I will happily check if what you wrote is good, if it doesn't perfectly match what I did. No worries. All right, one more problem we're going to do today. Why don't you try number 3 here on your own. So go ahead and pause the video, do A, B, and C for number 3, and then we will check our work together. All right, let's see how we did. Number 3 says, the table below shows the number of pieces of candy in a child's bag as they proceed to houses while they trick-or-treat the night of Halloween. Nice. All right, so X, our input, is number of houses. F of X, the number of pieces of candy, our output. Okay, so find F of 40. So that means 40 houses. When they did 40 houses, they had 152 pieces of candy. So explain what F40 means in the context. Well, I just basically did. So after going to 40 houses, they had 152 pieces of candy in their bag. They also had a very large sweet tooth. Okay, why does f of 0 equal 0? This is a great question. So why does f of 0 equal 0? And it's pretty straightforward. How much candy would you have in your bag if you haven't gone to any houses yet? So why does f of 0 equal 0? They had no candy in the bag because they haven't gone to any houses yet. Excellent. All right, and that's that. Raise your hand if you maybe got some different answers. You're not sure if they're right. Feel free to raise your hand. I will happily come around and help out. Otherwise, we talked about a lot today. We talked about applications of functions. We talked about reading functions from graphs, reading functions on tables, and of course evaluating function equations. All right? So, Mr. Carter signing off. I will see you next time.